Hi, we're going to be looking at Lesson 6.2b, Solving Linear Systems of Equations by Substitution. So let's first start off by reviewing what we did the other day. On number 1 here we see a system of linear equations, and what we want to do for the substitution method is to take a look at which equation is solved for one variable, so which one says x equals or y equals. But if you look, neither one of them do. So we're going to have to isolate one of the variables. We would either have to get the x or y by itself in this equation or get the x or y by itself in this equation. Do you notice that with the bottom equation, this y is kind of by itself already? All I'd have to do is take away the 3x, and I could do it in one step. Let's try it. If I subtract the 3x from this side and this side, I would get y is equal to 18 minus 3x. Now remember, we're not trying to write this in slope-intercept form. We're just trying to get the y, or x, by itself. So I've isolated the y, and y is equal to 18 minus 3x. So y is 18 minus 3x. So I've just boxed up that package, that expression, and now what I can do is take it and substitute it into the other equation in place of y. So I'm going to write that other equation again. 4x equals 3, and times y, make a big parentheses for the y, because I'm going to be substituting something in there in a minute. Okay, so do you remember this package over here, right here? We're going to take this, y is equal to this, so I'm going to plug it in for y, 18 minus 3x. That's what y is. So now you'll notice that I have an equation with just one variable, an x. So now I can solve. 3 times 18, 54, minus 9x, then I'm just going to drop the 2. Okay, so now on this side it looks like I can combine like terms. 54 minus 2 is 52. Now I'm going to want to get the x on one side. This one's bigger, so let's add the 9x. Okay, my last step to divide by 13. And x is equal to 52 divided by 13 is exactly 4. So x is equal to 4. So I have found my x coordinate. So over here in the solution, I'm just going to put x is 4. All right. Now remember, what I need to do again now is substitute a second time. X is equal to 4, so I have to find y. So I'm going to plug it into either of the equations, but remember yesterday I had told you that it's always easiest to plug it into the equation with a package. So here it says y is equal to 18 minus 3x, and x is 4. So y is equal to 18 minus 3 times 4. Well, 18 minus 3 times 4 is 18 minus 12, which is 6. So y is equal to 6. So right over here in my solution, 6. So it looks like these two equations, if they're graphed on a coordinate plane, they're going to cross at the point 4, 6. There's my solution. Okay, so that's what we did the other day. The only difference in this one was it took a little bit more time because we had to get the y by itself right here. Okay, let's take a look at number 2. Taking a look at the two equations, one of them is solved for either x or y. Do you see it? Go ahead and put a box around it. That's going to be our package. Y is 2x plus 1. So we are going to replace this expression, or this entire package, into the other equation right in place of y. So I'm just going to copy this equation. Big parentheses for the y. And then remember that the y is 2x plus 1, so that's why I'm going to be plugging in for the y, 2x plus 1. Now I have an equation with just one variable in it. So let's distribute. Be sure you're distributing the negative 2. Negative 2 times 2x. Negative 2 times 1. And then I'm going to drop down the 4x in front. Oh, looks like here, 4x minus 4x, isn't that just 0 and it cancels out? Oh, okay, so here I end up with negative 2 is equal to 6, and the variable completely canceled out. Now, is it true that negative 2 is equal to 6? No, that is not true. Do you remember what that means when you solve an equation? The variable cancels out and you get a not true statement. Remember what that means? It means no solution. So here I would get no solution. Now what does that mean for a system of equations? Remember, no solution means that the lines are never going to intersect. The lines are going to be parallel. So these two lines should be parallel. Well, I can check my answer. The slopes should be exactly the same for my lines. So you notice here with this equation, the slope is 2. That means this equation should have a slope of 2 also. I'm just going to check my work real quick. I'm going to rewrite this equation, y equals mx plus b. Now you wouldn't have to do this, I just want to show you. Do you see how the slope is the same? This equation has a slope of 2 and this equation has a slope of 2. So in fact they are parallel, so it would make sense that the solution would be, there is no solution, they're parallel. All right, let's take a look at number 3 and see what's going to happen here. Take a look at the equations. Which one has the x or y already isolated where we can box up our package? Top one, right? Right here. So x is negative 2y plus 5. So I'm going to replace the x in the other equation with negative 2y plus 5. All right, let's copy down this equation right here. Instead of x, I'm going to put a big parenthesis because remember I'm going to be replacing that x. I'm going to be replacing that x with negative 2y plus 5 because that's equal to x. Okay, now I have an equation with just one variable. Let's go ahead and distribute. Negative 6 times negative 2, 12. Negative 6 times 5. Looks like I can clean up this side a little bit by combining like terms. Negative 30 plus 24 is negative 6. Okay, take a look at what we have here. We have a 12y on both sides. Well, 12y is equal to 12y take away 6. That could never be equal. This side would always be 6 less. You know that 12y is equal to 12y, right? But if I subtract 6 away from this side and not this side, they're never going to be equal. So already you probably notice there's something wrong here. Well, let's take it a step further. I see that there's a y on both sides. If I were to move to the bigger party, they're both the same size. But to move, I'd have to subtract 12y. By doing that, 12y minus 12y is 0. Here it's 0, and I'm left with a negative 6. My variable canceled out completely. And again, I'm left with 0 equals negative 6, a not true statement. 0 is not equal to negative 6. So therefore, because the variable canceled out, and I get a not true statement, there would be no solution. No solution. Okay, well that means if there's, if there's no solution, again, these lines are going to be parallel. Well, let's just check our work. Well, actually, let's not. I could check it, but it would take me quite a bit of time to rewrite these. So I think you can just trust me that the slopes are going to be the same. Okay, let's move on. Let's take a look at number 4. This one's on the back side of your notes. Okay, so number 4, it looks like we have one equation written in y equals mx plus b. Solve for y. Y is by itself here, so I could put a box around this and call this my package. Y is equal to 1/2 x plus 3. So I'm going to replace that right into the other equation in place of y. I'm substituting. Well, let's take this equation and rewrite it. But remember, leave a big parenthesis for the y. Okay, so y is half x plus 3. So I'm going to put half x plus 3 right in here for y. You got that? Right in here for y. Half x plus 3. Now I have an equation with just one variable, an x. So let's go ahead and see if we can solve. 2 times half, half of 2, that's 1. 1x. 2 times 3, 6. Okay. Looks like we can combine like terms. X take away an x. Well, x take away an x is no x. So the x just disappeared, and I have 6 equals 6. Oh, and 6 does equal 6. Now notice that the x canceled out, and I am left with a 6 equals 6. Do you remember when we were solving equations before when the variable canceled out and we ended up with this? It was called an identity. They were identical on both sides. And what that meant was that there are infinite solutions. Well, what does it mean if a system of equations has infinitely many solutions? Well, that means that it is one line, and the second line is graphed right on top. So right on top here of the other line. So that means that both of the lines are exactly the same line, or exactly the same equation. So I just want to show you that real quick. And like I said, I normally wouldn't do this on everyone. I just want to show you here the first equation is y equals 1/2 x plus 3. And if I take the other equation and I rewrite it, solve it for y, do you see how the other equation is exactly the same? So both equations are the same, which means that they would be coinciding and have infinitely many solutions. All right, let's take a look at the last example. With the last one, it looks like we're going to have to isolate either the x or the y. Might be easier to look at the second one. Do you see how this x is right here kind of by itself? All we would have to do is take away the 6y. So let's do that. We'll take away 6y from both sides. That's going to give us x equals 10 minus 6y. So now I have a package here. X is 10 minus 6y. So I'm going to take that package, go and plug it into the other equation right in place of x, because it says x is 10 minus 6y. So let's rewrite that equation, the top one here. Remember, in place of x here, we're going to put a big parentheses. Okay. And I'm going to take this package, this expression, 10 minus 6y, because it is equal to x, I'm going to plug it right in here for x into the other equation. Remember, that's right here. So 10 minus 6y. Now I have one equation with one variable to solve for. So let's distribute. Half of 10, 5. Half of negative 6y is negative 3y. All right, let's take a look at this side and let's clean this up. Negative 3y plus 3y, that's 0, and it cancels out. I'm left here with 5 equals 5. Again, the variable canceled out, and I am left with an identity, which means that it is infinite solutions. Again. Okay, and that means that it's the exact same line. So if I were to take the time to rewrite these, both y equals mx plus b, they are going to be the exact same equation. Okay, so let's take a look at our summary down here at the bottom. This might look pretty familiar if you think about what we learned in chapter 2, I think it was. So our summary, if our variable cancels out and we end up with a statement that is not true, that means there is no solution. So not true means no solution. And that looks like a set of parallel lines. They're never going to intersect, and so they are not going to have a solution. Now, what if my variable cancels out and I end up with an identity where like 5 equals 5, like right up here, okay, where they're identical on both sides? That means I have infinite solutions. Remember, these both start with an I. Okay, and again, if it's infinite solutions, that means it's one line, graphed right on top of another line. They're coinciding, they're exactly the same line, so they're going to share all points in common. All right, well, there you have it, lesson 6-2B. Have a good day.